In Lecture C, we get into not only the heart chambers, but also the heart valves, and we start to introduce in the next section how blood flows through the 15 steps of the coronary system. So we know that we've already said there are 4 chambers of the heart. You had the superior 2 atria, and inferior to those you have the 2 ventricles. So we know that the atria receive blood from veins, and then they are going to pump the blood into the ventricles, and the ventricles then are going to pump it out of the heart. In between the atria and ventricles, though, there are specialized valves that are there which act like flaps or doors to close off the atria, close off the ventricles, to keep blood moving forward. They're there to prevent backward flow of the blood. So the valve's major function is to keep blood from moving backward to allow one-way flow. We know that the ventricles are much larger than the atria, their walls are much thicker than the atria, and that's because the ventricles are the primary pumping structures. They're under great deals of pressure as they begin to contract the cells within the ventricles and pump the blood to the systemic circuits. So that generation of pressure is necessary for both the pulmonary and the systemic circuits to function correctly. So when the ventricles are contracting, we know blood is ejected out of the ventricles into the arteries that are either going to take it via the pulmonary circuit to the lungs or the systemic circuit out to the tissues. The atria aren't symmetrical. Their size is different, their shape, and also their location. The right atrium is a little bit larger, and it has a much thinner wall than the left. The left atrium has the thicker wall, but it's smaller, and it's closer to the posterior side of the heart, where the right atrium takes up more of the anterior surface of the heart. So we know that the left atrium is actually the heart's base, which is the posterior surface, external surface of the heart. The atrium has these pouches, so both the left and the right atrium have these extensions of the atrium, which are known as auricles. So the name comes from your external ear, which is your auricle, and their resemblance to that. So as they lie over the external surface of both atria, they allow more space to hold more blood. So the auricle to the right atrium is much larger than that of the left, and that again is because the right atrium is a larger chamber than the left. Inside of the atria, you have the walls of it that contain these muscular ridges that are known as pectinate muscles. So especially the right atrium, you can see where these pectinate muscles come off the surface of the chamber. The left atrium that is forming the pulmonary veins, its inner walls are much smoother than the right atrium. So the pectinate muscles are primarily seen in the right atrium. You also, between the 2 atria, you have the interatrial septum. So this is the thin wall that separates the right atrium from the left. You have also a leftover from the fetal heart. Fetal hearts, you aren't allowing the right ventricle to pump blood to the lungs because the fetus isn't breathing. It's in the amniotic fluid, so it has a hole in between the right and the left atrium known as the foramen ovale. So the interatrial septum has this hole, so as an adult it winds up growing over and you have a small indention, which is the remnant left over of the foramen ovale, and it's known as the fossa ovalis. The fossa ovalis, so found in the interatrial septum. The ventricles, just like the atria, you have both the right and the left, and they're a little bit asymmetrical also. The right ventricle is wider, has thinner walls. The left atrium is much thicker and much larger because of the pressure differences. You have the pulmonary circuit, we've already said, is less pressure than the systemic circuit. So the right ventricle is going to have little resistance to allow the pumping of the heart to happen and to get that deoxygenated blood right over to the lungs, which are lateral to it. Where the left ventricle has much greater resistance and has to work harder than the right ventricle, so it has a much greater muscle mass within the myocardium, and you can literally see that the wall is about 3 times thicker than the right ventricle. As far as internally, the ventricles have a ridged surface in the lining of the chamber, where cardiac muscle tissue has these irregular protrusions that are called trabeculae carneae. So the trabeculae carneae is in the walls of the ventricles. They also, off of the wall, have these finger-like projections from the surface of the chamber that are known as papillary muscles. Each papillary muscle has a set of tendon-like cords that are known as chordae tendineae. They attach to the valves, which are the AV valves between the atria and the ventricles. So the lining of the ventricles, known as trabeculae carneae, the ridged surface protrusion of the cardiac muscle tissue, an extension of that into these finger-like projections would be the papillary muscles, and attached to them are these tendon-like cords that are going to attach to the AV valves between the atrium and ventricle that are going to again keep that one-way flow of blood. The muscular wall that's much thicker, you have the interventricular septum that separates the right and the left ventricle, and again contracts the rest of the ventricular muscle. So it literally is there to help expel blood into the pulmonary trunk on the pulmonary side and the aorta on the systemic side. So again, you have the anatomy of the internal heart to label in your lab book, and of course the quizzes to practice with this, and of course on the major quiz to label both the exterior and the internal anatomy of the heart.